Hello, this is a part 7 and the last video in the video series of Special Shear Wall Design Using a Test program. The content of this video is the difference between shear wall versus column versus wall wire. So this is an important topic because each type of element has different design procedures and various stiffness criteria. For example, if you have a wall and if the wall is cracked, then the stiffness modifier or the crack section property that you use is 0.35 of the cross section property in case of bending, etc. So, for example, you can consider 35% of the cross section property. First six, you can consider 35%. However, in case of actually shear wall, um, F22 is the one which works, and M11, M22, you can consider this 0.01 if you don't want any outer plane bending moment to be considered. But I would suggest that you consider bending modifiers as 35%. And in the first three, you can consider the F2 as 0.35 and 5 and keep the F11 and F2 as 1. However, considering this 1 does not make any difference because it has actually, and in practical, F22 is the main modifier for the shear wall, and M1 and M2 are the main modifier for the out of plane bending. And in case of a spandrel or the coupling beam, which we call spandrel in ETAPS, F11 is the major modifier. F22, F33, F12, these are not actually required. You can leave them as one or you can change them. Actually, this will not cause any remarkable effect in the design. So in case of shear wall, these are 0.35, but in case of column, what is the factor? In case of column, if the column is cracked, then you consider the column stiffness modifier as 0.7, right? 0.7 for the I22 and I3. But what if your consideration of the member is not correct? Say, for example, the member dimension here is 1630. So if you divide the larger dimension by the smaller dimension, 30 divided by 16 is 1.88, or you can say 2. So in case of special moment frame design or SDCD, a column, you cannot call it a special column, a special moment frame column, if the largest dimension is 2.5 times higher than the lowest dimension. So they give a ratio that largest dimension divided by lowest dimension equals 0.4. So you cannot go below it, or in other words, you can say that the larger dimension divided by smaller dimension equals 2.5. You cannot go beyond it. So if you go beyond it, you cannot consider that a column. So what will it be if it goes beyond the 2.5 ratio? Will it be a shear wall? So there is another dispute about it. The dispute is solved under the wall wire section. So the code says the NHFA has documented the code guideline here. It says that a wall wire is a relatively narrow vertical wall segment that is essentially a column. So wall and wall wire are different. Wall is a very long member, okay, and wall wire is not that long, okay, but whose dimensions do not satisfy requirements of special moment frame columns. It means for special moment frame columns, the dimension ratio should be less than 2.4, sorry, 2.5. So wall wire dimension ratio is greater than 2.5. Okay. According to ACI 318 section this, a vertical wall segment is to be considered a wall wire if length divided by width, which is the length is the larger dimension of a member, cross-sectional dimension, largest cross-sectional dimension is a length LW, and smallest cross-sectional dimension is a BW. If it is less than 6, but it is less than 6, and there is another ratio, this with respect to the height divided by length is greater than 2, then your member will be considered as a wall wire. It's not a special moment frame column because the ratio is greater than 2.5. Again, it's not a real shear wall, rather it's a wall wire. So what's the difference between a wall wire and a special shear wall? In case of a wall wire, these requirements apply. Okay. ACI 318 requires the wall wires to satisfy the special moment frame requirements for columns contained in ACI 318. It means that the hoops reinforcement requirement or the transverse reinforcement requirement as per code, or for example, the 8354 will be applicable completely for the wall piers. Say, let me take you there. 834, 8345. This is a transverse reinforcement requirement, and there are two formulas, 0.03 and 0.09. And in case of a shear wall, we said that this formula is not applicable for boundary element, right? But in case if it is not a shear wall, rather if it is a wall pier, then you have to apply both these formulas and provide tie reinforcement or hooks reinforcement based on this two formula. And also for shear wall, you did not have to comply this. 1/4 was not applicable, 1/3 was the applicable ratio, but 1/4 will be applicable for wall pier. Okay. So what is the difference between wall pier and shear wall? The difference is the similarity. Let's first talk about the similarities. The similarity is the crack section property will be like shear wall. 0.35 is the crack section properties or stiffness modifiers that you will apply in your wall pier. But the detailing will be like column, special shear, special moment frame column. Okay, that's the difference between the shear wall and a wall pier. But what is the difference between wall pier and a special moment frame column? The difference is in a special moment frame column or a column, you apply 0.7 as your stiffness modifier or the crack section property in I22 and I33. But in shear wall, sorry, in wall pier, you apply 0.35. So this is a major difference actually. And the design will be as per the design forces you get from the model. There won't be any differences. You can model it as a shear wall in your program. That's okay. That's not a problem. However, you have to have some judgment regarding your design of transverse reinforcement and application of the crack section properties. So these are the major things. Okay, thank you. I hope the video was helpful to you to understand about wall pier, column, and shear wall.